The perceptron algorithm. The perceptron algorithm, it's a type of linear classifier that attempts to find a separating hyperplane between two classes of data. That is, let us say you have a lot of data that corresponds to class C1 here. Let's say all these data are of class C1. So this is C1. And say there are some other data here. All this data, this corresponds to class C2. So all these data points are of class C2. What does the perceptron algorithm do? It will come up with a separating hyperplane which will separate these sets of data. So maybe that hyperplane will go somewhere like this. And what is the speciality of this hyperplane? Above this hyperplane, all the points belong to C1, and below this hyperplane, all the points belongs to C2. So this is one of the simplest and earliest algorithms used for supervised learning of binary classifiers. So how does this perceptron algorithm work? What it does is it will update the weights, that is the weights W. It will update it iteratively based on misclassified examples. Each time it will try to classify points. If there is a misclassification, it will update its weights so that finally you get the right weights. And eventually you will reach the decision boundary, that is this particular line. So let us understand this in detail. So in order to classify these points, the first thing you need is a function. So you have a function, let's say W transpose X plus W0. This is the function that you have. So if you know W, then given any point X, you will be able to find the value of W transpose X plus W0. Let's call this as A. So how does the perceptron algorithm work? Let's understand that first. In perceptron, you first have a function which is A equal to W transpose X plus W0, but that's not all. We'll see the difference between what we saw earlier and what is the speciality in perceptron algorithm. Okay, let us say you have this function A is equal to W transpose X plus W0. So till this point it is same like whatever you had seen earlier. X is the input, W is the coefficient matrix. So you have the coefficients W and W0 is the bias. So generally you include W0 into W and make a single vector, or if you are considering bias separately, that's also fine. The perceptron algorithm, the perceptron function is like a step function. So it is something like this. F of A, this is equal to 1 if A is greater than or equal to 0. If you find this value W transpose X plus W0, if that value comes greater than or equal to 0, then F of A is 1. And F of A is minus 1 if A is less than 0. This is the perceptron activation function. This is called as activation function, F of A. So in total you have F of W transpose X plus W0. This is what perceptron does. It will take this function, which is a step function. It will first find out W transpose X plus W0. If that value is greater than or equal to 0, then the step function will give you answer 1. If the value is less than 0, then the function will give you the value minus 1. This is how the perceptron works. The next question is, how do you train the perceptron? That is, if you give any data point X, it should be able to compute the value of A, and from that finally able to tell you that, hey, this class belongs to 1 or this class belongs to minus 1. So you can map maybe 1 is class 1 and minus 1 is class 2. So here the perceptron will exactly tell you that it belongs to 1 or minus 1. But for this, you will have to train the perceptron. Let us see how do you do this training process. Okay, this is the crux of this. So keep this in mind that there is a step function. This step function is supposed to tell you 1 or minus 1. And the most important part is, by training the perceptron, you have to identify the W's, W0 and W. Once you identify that, the remaining is simple because step function is straightforward. Once you have A, if it is greater than or equal to 0, it is 1. If it is less than 0, it is minus 1. This part is straightforward. What is difficult is finding the value of W, which will give you the right value of A. Because if value of A is correct, then your classification will also be right. Okay. So let us understand how A is found, how W is found. Basically, if you know W, then you know A. So let us say your data is something like this. X is equal to, let's say, x1, x2 up to, let's say each input is d dimensional, then up to xd whole transpose. So each input is d dimensional and correspondingly you will have coefficients W. W is equal to, let's say, W1, W2 up to WD. This is the set of coefficients that you have. And the next thing is the bias term. Bias term is W0. W0, it represents the offset of decision boundary from the origin. That is, if you write the equation of a line, it will be y is equal to mx plus c. So this c is the y intercept. So this intercept, which is the offset from the origin, that is what W0 denotes. Okay. So you have W0, you have W, you have X. If you find out the right values of W and W0, your task is done. Let us I understand the perceptron learning algorithm. One more term before we go to the learning algorithm, there is a term called eta. Eta is called as the learning rate. This learning rate, it controls the size of weight update. That is, how fastly do you want your model to learn or how slowly do you want your model to learn. So it's important that you adjust the learning rate correctly so that the model is able to reach the optimal solution. If you make it faster, that is, if you make each step very large, maybe it will be difficult for the model to converge. Each step will be very large, but it will be difficult to converge. So we'll see this. Okay, so keep this in mind. You want to find out A. This is the X that you have. Each input looks like this. It will be d-dimensional. Then this is the W. That is the coefficient that you want to find, and W0. Okay. Let's start with the perceptron learning algorithm. So the first step in perceptron learning is to initialize the weights and bias. That's all the W's you have to initialize, and the bias W0. You have to initialize W and W0. Generally, you will initialize it to very small values or sometimes to zeros. It's up to you. Whatever kind you want to do, you can do. So either keep very small random numbers for initializing W and W0. Otherwise, you can initialize with 0. That will also work. Okay. So this is the first step. Once you initialize, the second step is to start the training loop. How is the training loop? For each of the training example xy, let's say xi, yi is the ith training example. For each of these example, what do you want to do? What is xi, yi? Xi is your d-dimensional input, which has x1, x1i, x2i up to xdi. This is your xi. Xi is a d-dimensional input. And what is yi? Yi will tell you the output. That is, what should be the output of A. It should be either greater than 0. If the activation function, it will be 1 or minus 1. So you want to know the final output Y. That is, which class does it belong to, and the input X. Once you get both this, what will you do? You will calculate using the activation function. So you will say the yi that I am finding is, so using this xi, you will try to find the yi. Okay. You have the value of yi, which you will use for comparison. Now you are first trying to identify yi from the present values of w and w0. So I'll call it yi cap. This is equal to f of w transpose xi plus w0. So this is my yi, f of w transpose xi plus w0. This is what I'm finding using the present value of w and w0 that I have. Now there are two possibilities. One is that I identified the right class, the value of yi cap, the value of yi cap that I have, and the value of yi that is given in the data. Both are same. This is one possibility. That is, it was actually belonging to class 1 and I identified it as class 1 only, using my presently existing values of w and w0. This is one possibility. If this is the case, then you don't have to do anything in this particular run. That is, for xi, yi, this particular point, you don't have to do anything. You can take the next point and continue the iteration. Otherwise, if this is not the case, if yi cap is not equal to yi, in that case you have to update the weights and bias. How do you do that? In case the yi that you found and the actual yi are different, in that case, how do you make updates in Perceptron? You have to find w and w0. So I'll write here. This is the yi cap that we tried to find, f of w transpose xi plus w0. This is the yi cap that we found, and under the condition that yi not equal to yi cap, in this condition what should you do? You should update both the weights. So one is w. How will you update w? W will be updated to present value of w. W will be updated to present value of w plus eta into yi minus yi cap into xi. This is the updation that you have to do for w. So your w will be updated to w plus eta into yi minus yi cap into xi. So yi minus yi cap, this is the difference between the yi that you found and the expected yi. This you will multiply with xi, which is the data point, and the eta is the learning rate. So here is the importance of learning rate. If learning rate is set very high, there will be large steps of learning because of which it may not converge. So in order to make it converge, you have to choose the right learning rate, which is not so large, not so small, which is correct for this problem. And the second thing you have to update is w0. How do you update w0? Your w0 can be updated as existing value of w0 plus eta into yi minus yi cap. So this is how you will update w0. So this is the training loop that you have to go through. For each of the point xi, yi, you have to repeat this again and again. Take one point, compute yi cap, see whether yi cap is equal to yi or not. If it is not equal, in that case, do these updations, both these updations. W can be updated to w plus eta into yi minus yi cap into xi, and w0 should be updated as w0 plus eta into yi minus yi cap. This you have to continue doing till what point? That is the question. When should you stop doing this? So there are two possibilities. First possibility is, it can so happen that all your training examples get correctly classified after some particular iteration. Let us say you took all the training examples one by one. Again, you passed all the training examples one by one. Again, you did, let us say you did this for maybe 10, 20 or 25 times. Maybe after you did it for so many times, it so happened that in one iteration, all the points got correctly classified. That is, there is no more updation to be done. Whatever point you gave, your Perceptron correctly classified everything into the right class. yi is equal to yi cap in every single case. Then there is no more training to be done. You are done. So this is one case. If that happens, that is, there is no more training to be done, everything is correctly classified, that is from the training data, then you can stop. That is a converged position. You can use that Perceptron for whatever task you want to do after that. So your Perceptron training is done. What if this is not done? If you already ran it for, let's say, 100 iterations, still you don't see this complete convergence. That is, you're not able to reach a position where all the points are correctly classified. If that happens, then what do? You keep a maximum number of iterations. That is some threshold T0, let's say. Once this threshold number of iterations are crossed, let us say you said 100 is my threshold. So if it goes for a maximum of 100 iterations, then I'll anyway stop training my Perceptron. I'll consider that it is converged. So these are the two conditions under which you can consider Perceptron training as finished, or you have completely trained the Perceptron. The first case is when there are no more misclassified points. In this particular iteration of the loop, all the points got correctly classified. That is first case. Secondly is that it reached the threshold that you had set, maximum number of iterations, that you can manually set that this is the maximum number of iterations that I want my Perceptron to go for. So these are the two cases. So this is about the perceptron algorithm. You understood that how we want to find W and W0 and how we can apply this. So perceptron algorithm, you understood that it iteratively adjusts the weights and bias, and then it finds a linear decision boundary that separates the two classes. This is what the perceptron does. So it does this by updating the weights and bias for each of the misclassified example. Keep in mind that only when it is misclassified, it will do this updation. If it is already correctly classified, it won't do this updation step. And gradually it will converge to a solution that correctly classifies the training data. That is the perceptron algorithm. One more point before we end this lecture, that is the perceptron algorithm. It always guarantees convergence if the data is linearly separable. So keep this point in mind. If the data is linearly separable, that is, if it is possible for you to draw a clear decision boundary with which you can say at one side of the decision boundary it is class C1 and the other side it is class C2, in such a case, that is if the data is linearly separable, then convergence is guaranteed in perceptron algorithm.